Have you ever pondered the sun's immense power and its potential impact on Earth? It's not just a glowing ball in the sky, but a colossal fusion reactor churning out energy that fuels life here on our little blue planet. Its warmth allows plants to photosynthesize, creating oxygen for us to breathe. Its light guides our days, and its gravitational pull drives the tides. But there's more to our sun than meets the eye. This radiant star doesn't only nurture life, it can also pose a threat in the form of solar storms. These are massive eruptions that spew out charged particles into the cosmos, and sometimes towards Earth. While we enjoy basking in the sun's life-giving glow, it's vital to remember that its power can be a double-edged sword. The same energy that fuels life can also disrupt it. So, what exactly are these solar storms and how can they affect us? Let's delve deeper. Solar storms, also known as solar flares, are sudden, powerful eruptions that occur on the sun's surface. These natural phenomena are not only fascinating, but they also have a profound impact on our planet. To comprehend the science behind solar storms, we must first understand the sun's magnetic fields. Think of these magnetic fields as invisible lines of force that originate from the sun's core. These fields are constantly in motion, driven by the sun's rotation and its seething, churning surface. Over time, these movements twist and contort the magnetic fields into complex, tangled shapes. Now, here's where it gets interesting. The sun's surface, or photosphere, is a seething cauldron of plasma, a superheated state of matter composed of charged particles. Occasionally, the twisted magnetic fields can snap and reconnect, creating what we call a solar flare. This process releases a tremendous amount of energy, equivalent to millions of hydrogen bombs detonating at once. But wait, there's more. Sometimes these solar flares are so powerful that they hurl a cloud of plasma into space. This is known as a coronal mass ejection, or CME. Traveling at speeds of up to a few million miles per hour, these CMEs are the primary cause of geomagnetic storms on Earth. Now, you might be wondering, how do these charged particles from the sun reach our planet? Well, it's all thanks to the solar wind, a constant stream of charged particles flowing out from the sun. When a CME is launched, it can create a shock wave in the solar wind, accelerating particles to near the speed of light. These high-speed particles can then reach Earth in just a few hours. Upon reaching our planet, these particles can wreak havoc on our technology, disrupting power grids and communications. But they can also create a beautiful spectacle in our skies, known as the auroras. These storms may seem like a distant cosmic event, but their effects can be felt right here on Earth. You might be wondering, how can these solar storms affect us on Earth? Well, the repercussions can be quite significant. Picture this. You're sitting at home and suddenly the lights flicker out. That's because solar storms can cause major disruptions to our power grids, leaving entire cities or even countries without electricity. But it doesn't stop there. These storms also wreak havoc on our communication systems. Imagine trying to call a friend but your phone has no signal. Or you're a pilot, navigating a plane full of passengers and your radio goes silent. That's the kind of chaos solar storms can unleash. And let's not forget about those brave souls venturing beyond our atmosphere. Astronauts and air travelers are exposed to increased radiation during solar storms, posing a serious health risk. So, while we enjoy the sun's warmth and light, we must also respect its power and potential for disruption. Today, we've journeyed into the sun to understand the fascinating and potentially devastating phenomenon of solar storms. These massive eruptions from the sun, hurling charged particles towards Earth, are a testament to the incredible power held within our own star. We've delved into the science behind these storms, unraveling the complex interactions between solar material and the Earth's magnetic field. We've also shed light on the potential impacts of these solar storms on Earth. They can disrupt power grids, interfere with communications, and pose risks to astronauts and air travelers. The power of the sun, it seems, extends far beyond providing us with light and warmth. Understanding this phenomenon is of utmost importance. As our dependence on technology grows, so too does our vulnerability to these cosmic events. As we continue to explore and understand the cosmos, we must remember that even our own sun holds secrets and power that can have a profound impact on our daily lives.